As you can see from our notes section, this video is going to be sandwiching in really two sections, even though it's only titled 6.2, because we're going to be both using properties of parallelograms and also, like from 6.3, using them to prove that we have a parallelogram in the first place. So a parallelogram is what we're talking about as a quadrilateral with both pairs of opposite sides that are parallel, so we can see that marked in this first figure. And the parallelogram symbol with that parallelogram shape is going to be something we can use, much like our triangle symbol, just to reference that if I don't want to write that out. Quadrilateral opposite sides, if I want to state that sides are opposite, they don't share a vertex, and opposite angles, same thing. We're just pretty much thinking the opposite side or opposite angles across from that parallelogram. So A and C, opposite angles, AB and CD, for example, opposite sides. And if I want to state a few properties of a parallelogram, and again, also from 6.3, using that to prove a parallelogram in the first place, our first one is that in our parallelogram, again, if a quadrilateral is a parallelogram, opposite sides need to be congruent. So again, starting with the fact that we have a parallelogram in the first place, if I know it's a parallelogram, that's because the opposite sides, so like AB and CD, for the left and the right, and also BC and AD for the top and the bottom. Those should be matching and those should be congruent. Should see it, those have congruency markings. Notice they don't all four have to be congruent to each other, but I should see two pairs that are congruent. And again, if I want to reverse that statement, that's what we say a converse. If I want to prove that something's a parallelogram, I could find that both pairs of opposite sides are congruent, and that would prove that we have a parallelogram, because what we're really doing is just reversing that first property. So again, that's kind of what we talk about 6.3, proving that something's a parallelogram, is just by finding that it has those properties. So besides of opposite pieces of a parallelogram, you can also talk about consecutive. So consecutive angles, for example, A and B. You can kind of think consecutive just means that they're next to each other or that they share a side. A and D, for example, is another one. B and C, C and D. So any two that appear along the same line would be consecutive. And if I want to use that again to state another property, I can state that if we have a parallelogram, so again, using the property of the first that we're told, if I have a parallelogram, it's because that we have those consecutive angles that are not congruent to each other, but instead supplementary. So A and B, if I add those up, again, should make 180. It's also kind of thinking back to where we're talking about consecutive interior angles. BC, those are going to be supplementary. CD, those are going to be supplementary. It needs to be true for every one of my angle pairs for that to be supplementary, or for that to be a parallelogram, rather. And like we said with our last rule, we can also reverse that for a converse. So if I want to show that something is a parallelogram as a conclusion, I can start off with a starting point that, again, if A and B are supplementary, that's one pair. If A and D are also supplementary, really we only have to show it at that one corner. Angles with quadrilateral are supplementary to both of its consecutive angles. As long as we've shown it twice with both of those pairs, that is going to be proof that we indeed have a parallelogram. Because then it has to be true going all the way around our figure. You can imagine if A is, let's say, like 60, then we have a 120 for B, then we also have a 120 for D, and that's going to be another 60 in that opposite corner for C, even though we haven't found it. Another rule we can state about our angles in a parallelogram is that if I do have, again, starting from my parallelogram, I know that opposite angles, so not consecutive this time, are going to be congruent rather than supplementary. So imagine for B and D marked with the same marking, A and C marked with the same marking, those are going to be our congruent angles. And like with our other rules, if I look at that converse and want to prove that something's a parallelogram, I can imagine that if those are congruent from the beginning, so opposite angles again in the opposite corner from my parallelogram, if those are congruent in both pairs, I will have a parallelogram. So that's yet another way to prove it if I don't want to use those sides. In our first problem, we actually do require the assumption that this figure that we're drawing is indeed a parallelogram, so I'm going to add that in as well. Assuming that we have this parallelogram, just with that parallelogram symbol, we can call that PQRS. If we're given just one angle from that parallelogram, angle S, we should be able to find the measure of angle P, which we call that consecutive angle, as long as we're aware of the properties of that parallelogram. So the first rule that I can state that if we want to state the measure that we're missing, angle P, if I add that to the measure that we're given, it looks like we're given the measure of angle S, I know that those two should be a sum of 180 because, again, we know that if I have a parallelogram, this is coming from my starting point that we had to establish before. It's not really marked for us. But if I do have a parallelogram there, it means that those consecutive angles, I was going to say opposite angles, those consecutive angles are going to be supplementary. So we can add that in for our reasoning in terms of how I'm able to start with that equation. But as long as we know that equation would be true, now I can just substitute in, again, measure of angle P we don't know, but I know that the measure of angle S is 64 degrees. Again, if that is going to be supplementary, that means that's going to be a pretty quick algebra question to solve in terms of what angle is missing. Take away 64 from both sides, and I get that the measure of angle P, the one that we're looking for, is going to be 116 degrees because, again, if I have those consecutive angles, they should be supplementary if I'm indeed dealing with that parallelogram. And if our last problem was talking about the angles and how we can use those to find a missing measurement, we should be able to do the same thing using side properties of a parallelogram. And here we're told what should y be, so we're only given y one place in this figure, in order for that larger shape PQRS to be a parallelogram, which is a little bit more like 6.3 in terms of proving that something is a parallelogram. But if I know that the opposite sides in my parallelogram are going to be congruent, I know that, for example, QR is going to be the same measurement as from P to S. So that is something I can say in terms of those expressions. Y is going to be the same length as x plus 2. But since we don't know what x is yet, we're going to have to solve that using yet another property that's still going to be the same, property that we're using, just the fact that those other two sides are going to be congruent as well. So PQ and SR are going to be the same length. And if we're going to be able to find y, I'm going to have to find x first, and then we can substitute that back in later. But now I know if I'm using that same property, the opposite side should be congruent. If this is indeed a parallelogram, I can say that that top expression, 3x minus 5, same as that bottom expression for SR, 2x minus 1. A couple algebra steps here, so add 5 to both sides, I get 2x plus 6. Subtract 2x from both sides, I get that x is going to be 6. But then again, since I'm looking for y instead of x to solve this question, I just got to go back to my equation that we have with y in it and just substitute my answer back in for x. So we know that, again, if y is going to be equal to x plus 2, so let's write that out. Y is going to be equal to x plus 2. That means that y is going to be equal to now 6 plus 2, now that I know what x is. And that's a pretty easy addition problem to figure out that y is just going to be 8 there. And again, the only property that we're really using to solve this is just the fact that opposite sides of my parallelogram should be congruent, so they're going to have that matching length. If we try that again with the next example, we're using, it looks like, angles this time for part B. But here I shouldn't really have to make this kind of opposite being equal equation, if you guys are thinking of that. Like, we do know that E and G would be the same measurement, and we also know that F and H will have the same measurement. But rather than using opposite sides being congruent, I'd rather use the two consecutive angles. I said sides, but yeah, that would be angles. So if I look at F and G, for example, the measure of angle F plus the measure of angle G, we know that those are not going to be congruent if this is a parallelogram, but since they are still consecutive angles, those should be supplementary. And if you can spot the reason why we're using those two angles instead of something like F and H as a congruency pair, it's because we're using the same expression or the same variable in both expressions. If x is the part of F and x is a part of G, now I can just replace that with 4x plus 13 instead of angle F. I can replace G with that expression for 12x plus 7. And now that I know that these are supplementary rather than congruent, I just have to solve this for x. I don't have to figure out y at the same time. So I get 16x plus 20, combining like terms, subtract 20 from both sides. We get 16x is equal to 160, it looks like. Divide both sides by 16, I think we get that x is going to be 10 for one of our answers. And now I can just take the same kind of approach if I'm looking for an answer for y, because that same idea still holds true. It looks like at E and H this time, those are two consecutive angles, so those two should be supplementary. Again, if this is indeed a parallelogram, so add those up, we get 180. And now if I just replace my expressions, it looks like E was 3y minus 2 from our diagram. H was y plus 10 from our diagram. And by the way, if you'd rather skip writing the parentheses, we don't really have to on that step. It may make it easier for you guys to combine like terms if you leave the parentheses out, but I just use that to say that's E, that's H, those are just our two expressions. But again, since those are consecutive angles, I know they're going to be supplementary, not congruent. Now I just have to take this and solve for my variable. So it looks like 4y is 172. If I divide that by 4, I think we get 43 on that one for y. So good to know both your rules for angles for a parallelogram. It would be possible to say that E and G would be congruent to each other, but since you would have to use y and x in the same equation, I'd rather look at those consecutive pairs instead. So E and H are going to add up to 180, F and G are going to add up to 180, and then as we've noticed, we're able to solve for one variable at a time.